Sorted subarray to be removed to make array sorted. Given an integer array ARR, remove a subarray from ARR such that the remaining elements in array are non-decreasing. Okay, so non-decreasing simply means increasing, right? No. Why? If it is, then they should have written increasing, but they did not, because then there would be a confusion whether they are talking about strictly increasing or increasing. What do I mean by that? So let's take an example. 1 2 2 5. Now, is it an increasing pattern? Yes. But is it strictly increasing? No, it's not strictly increasing. Why? Because in strictly increasing, the elements cannot be equal to the previous element, but in non-decreasing they can. So the only reason to say non-decreasing is to clear the doubt that elements can be equal to their previous element. Okay, now our objective is to return the length of the sorted subarray to remove such that remaining elements are non-decreasing. Okay, so let's take this example, which is 1 2 3 10 4 2 3 5. Now, one simple way is to consider the increasing pattern from the start, that is 1 2 3 10, and you remove everything else, that is remove all this 4 2 3 5. So in this case we are removing a subarray of length 4. Okay. Another pattern is to take the increasing pattern from the last, that is 2 3 5, and remove everything else. So in this case we are removing a subarray of size 5. Okay. But we can see that the answer is 3. That means there is some other ways to remove the subarray such that the array is still in non-decreasing order and the subarray removed its shortest. And the only way to do that is to consider few elements from the start and few elements from the end. Okay, so one way that can be done is take 1 2 from the start and 2 3 5 from the end, and remove everything else from in between, that is remove everything else from here. So in this, now we can see 1 2 2 3 5 is a non-decreasing pattern, and in this case we are removing a subarray of length 3. Another possibility is to take 1 2 3 from the starting and then 3 5 from the end, and in this case we are removing a subarray of length 3. Okay, so the shortest subarray that we can remove is of length 3, and so the answer is 3. Okay, now how can we approach this problem? The first thing to realize is that we have to consider the non-decreasing pattern from the start and from the end. We have to consider only these two non-decreasing pattern and nothing else. Why? For example, let's say we have a pattern like this. So there are many non-decreasing pattern. One is this, one is this, one is this, and one is this. And we have to remove a single subarray. So if we take this subarray, we can't merge it with this. Why? Let's call this 1 2 3 and 4. We can't merge 1 with 2. Why? Because if we do, then we have to remove two subarray. We have to remove this subarray, and then we will have to remove this subarray. which should be 2 subarray, but we only have to remove a single subarray. Okay, because it is to remove a subarray, so that means we only have to remove single subarray. So in pattern like this, we would have to remove everything from in between, and we only have to consider these two pattern, these two non-decreasing pattern, one from the starting and one from the end. And why are we not doing why aren't we doing whichever is longest from the starting or from then just return it? Because as we can see in example 1, we can get the optimal answer by merging by taking few elements from the starting and few elements from the bottom. So that means optimal answer can lie if we merge them. Okay, so let's say, so finding this pattern from the starting or from the end is key. Okay, let's say we have this 2 3 5, that is we have this subarray. Now we are trying to develop an algorithm to find this optimal match. So let's say we are taking all the elements from the end. So we have two patterns. Let's call this pattern 1 and let's call this pattern 2. So in our first try, we are taking all the elements from pattern 2 and we are removing everything else. So that is, let's say we are calling our answer to be, now since we are considering this, we are removing everything else. So that means our answer is 5. The subarray that we are removing is 5. Okay, now we would see whether we can merge with this or not. 1 2 3 and then 10. Okay, so now we would check whether the first element can be merged with this or not. So is 1 less than or equals to 2? Yes. So that means 1 can be merged with this. Okay, so that means we can remove everything else. So we would keep 1 and we would remove everything else, and then we would take 2 3 5. So that means we're removing just this part. So in this case our answer would be 4, and that is the subarray that we're removing is 4, and it's smaller than our previous answer, so we would update it 4. Okay, now we would see whether we can include this element or not. 2. Okay, so if we are including 2, that means we are including 1 also. Okay, so now we are checking whether this 1 2 can be included or not, and it can be, because 1 2 and then this 2 3 5. So that means, and this is this case, and in this case our answer is 3, so we would just update it again 3. Okay, now we are checking whether we can update this or not. 1 2 and 3, whether we can include this or not. So can we include this? No. Why? Because 3 is not less than or equals to 2. Okay, so what can we do? Can we just stop our algorithm? No. Why? Because there can be other optimal way that we are missing, like this is also giving 3, but we are not considering this, and maybe there can be case in another example where this would give an optimal answer. And how are we getting this? Okay, so since this is 3, that means let's say we have a right pointer here, then that means we have to move this pointer until the element in this part is greater than or equals to the element, let's call this left. So we have to move the right pointer until the right pointer is greater than or equals to the left pointer, and let's call this. Okay, so we move this here. Now we are considering 1 2 3 3 5, and we are removing everything in between. That means we are considering this case now, and it is also 3, so answer is our still 3. Now we would take this 1 2 3 10, and is this, so this, now 10 is not less than or equals to 3, so we would move this pointer. 10 is not less than or equals to 5, then we would move this pointer, and there are no element left. That means we are now considering this pattern, and here the answer is 4, but since it's not minimum, we will not update our answer, and so our answer is 3. So what we have done, we have first found the right, we have first found this pointer. Basically we are finding this pattern. How can we find this pointer? Just simply point right to array of n minus 1, where n is the size of array, and move right pointer. So do this while right is greater than 0, and what array of right is, array of right is what, greater than equals to array of right minus 1. Do right minus minus, and we would have, at then we would have our right pointer here when this loop ends. Now we have to consider elements from the starting until they are in increasing order. That means we would do left from 0, and we would move array of left until array of left is less than equals to array of left plus 1, and it is less than equals to, and also this left simply, and we would just check whether taking this element from the left. Now we just do this. So what we do, we would check whether, let's say this is right, so we would check whether array of right, if this is what, if this is less than array of left, then that means we have to do right plus plus. Okay, so until array of right is less than array of left, we will do right plus plus, and once this loops end, we will just update our answer to minimum of answer comma what, right minus left minus 1, and right minus left minus 1, it will give us the subarray that we are removing. So let's look at the algorithm. We are finding the, here we are just finding the starting point of this non-decreasing pattern from the last, that is we are pointing our right pointer to here, and now we are saying answer equals to right, that is we are considering this part and we are removing everything else. So that means we are removing everything else, so this would give us the size of the subarray. And now we are checking how many elements from the starting can we include in it. So first we are taking this, so now we are putting left here. Now we are checking whether we can include one with this. Okay, so now we can obviously move our right pointer until there's this element left, so while right is less than array dot size, and now we're checking whether array of left is greater than array of right. Like, since we want to increasing pattern, so we can only include this element if this element is smaller than or equal to this element, that is if array of left is less than equals to array of right, we can include it, otherwise we cannot include it. So if this is not true, then that means we can't include it. That means if array of left is greater than array of right, then we have to move the right pointer. So that's what we're doing. If array of left is less than array of right, then we're moving the right pointer. Now we have the left pointer, we have the right pointer, so everything in between would get removed, and that is right minus left minus 1, and we're checking, and we're just updating answer equals to minimum of answer comma length of removed subarray. And now we're updating our left pointer to here. In the next iteration, we check whether we can include this element or not, and finally we would return our answer.